135.1, 114.3. 137.7, 119.7, 140, 122.2, 142.2, 124.5. Mark 548. 146.5, 129, 126.9 rather. 148.6, 129.2. 150.6, 132.1. 152.2, 134.6. 154.2, 139.1. Mark 549. 155.8, 141.1. 157.6, 142.7. I'm just getting a high reading now on the right one, and the left one, 144.5. Looks like I've exceeded the temperature range of my probe. Let's turn these off now. While we're waiting out the return to room temperature of the gases in these two flasks, we should ask ourselves, how can we help our students generate questions? Not only that, but how can they then find answers to their own questions? That is the spirit of inquiry discovery. I'm hoping that this experiment raised several questions in your minds. The first question that I would think one would ask would be, how come the temperature shot up so much more quickly in the carbon dioxide? The next question might be, what if there weren't as much carbon dioxide in that flask? What if it wasn't filled with carbon dioxide? Look, there's a way we could only have half carbon dioxide. What is the amount of carbon dioxide in the atmosphere compared to the temperature of the gases in these flasks? Well, carbon dioxide is less than 1% of our atmosphere, but still helps warm the planet through the greenhouse effect. So a very small amount of carbon dioxide is actually affecting the temperature of our planet by, we think, about 50 degrees Fahrenheit. How does this experiment relate to the greenhouse effect and global warming? What about the cool down? Why did the cool down take as long as it did? Would it have helped if we had removed these lamps, since they were probably pretty hot? Now they're cool. I'm sure they were hot for quite a while after we turned them off. Might that have affected our experiment positively or negatively? Those are just some of the questions off the top of my head. And I'm sure there will be more, which I will include in the text of this lab. But having students analyze the data and then try to answer their own questions is really in the spirit of inquiry / discovery, the spirit that we're trying to foster in our children, the spirit that is too lacking in most situations. So I hope this experiment piqued your interest, not only in the effect of the heat retention properties of carbon dioxide, but also a way to teach it. Starting out with the dry ice, piquing students' interest about the substance itself, and then, of course, giving them practice recording data, looking at what a control is, and also generating real data that they might not know about in advance. They might have a few preconceived notions about what might happen. So, for now, this is Mr. Springel signing off. Thank you for your attention.